In this session, we are going to see what is a blockchain and the introduction of blockchain. Before seeing deep discussion of blockchain, just we want to think of a client server model. So as we know all that client server model is a method of working in sending the request to the central server and the response is sent back to the client. Since the data is centralized and saved in one spot, there is a high chance for attacking. Means the hackers can attack the data and compromise the data. And because it is centralized, if any software upgradation happens, the whole system will get struck. I mean, it will halt. It will get halted. So that is another issue with the central servers. And because central servers, if any of the system or any of the server is down, so it may not serve the client properly. And another worst case scenario is if any malicious viruses are attacked or anything is attacked, the data may be corrupted or hackers may try to compromise the data. So these are the different issues that we may encounter in client server model. So in order to overcome these kind of drawbacks, blockchain is introduced. So where the blockchain is a decentralized and distributed peer-to-peer network, and it is a public network. In blockchain network, there are several nodes interconnected together in peer-to-peer manner, where they can directly exchange the data within the network. So if you see here, because the transactions are distributed, instead of storing in single place, the copy of a data, the transaction is sent across everyone, which are called nodes to validate the transaction and send the transaction from the receiver to the from the sender to the receiver. Okay, so this way, this particular blockchain tries to work in, because it is a decentralized and distributed network. The data is not centralized, and there is no single entity which owns the entire data. Everyone is a participant, and everyone tries to contribute towards the security of the data and for the transparency of the data and trust of the data. That's how this particular network, blockchain network, is going to help us. So in blockchain networks, generally we see validator nodes and member nodes. Validator nodes, they can send the data and they can receive the data, and they can validate the transactions also. Member nodes, uh, they can only send and receive the transaction, or initiate the transaction, or the receive the transaction. So this is how this particular simple architecture of blockchain look like. So as we discussed in central server, what happening is the server is connected with many of the clients. So where each client has to request the same central server, and there may be as we discussed the issues and the drawbacks that may occur in central servers. Decentralized servers are also kind of central servers connected together, and further each server there may be different clients which are connected to, so requesting or looking for the services of the servers. This is the way how the decentralized will help us. And because different the servers are distributed, but further the data is other authorization should happen in any one of the servers. So that's how it will uh, be there in decentralized. When we think about the distributed ledger, as we know that the blockchain is a peer-to-peer network, each node is connected to each of other node which within the blockchain. so that the communication or the exchange of the data is peer-to-peer, which can be exchanged among the each node. So in distributed ledger or blockchain, we have public blockchain and we have private blockchain. In public blockchain, all the nodes are public. Anyone can connect to the public network and they will be anonymous. But in private network, these are not anonymous, but the known people, like few people connect together and try to form a private blockchain. So this is simple about the architecture of the networks and blockchain. So once we see in this particular blockchain network, now the next step is what is being transmitted through the network. The blocks will be transmitted, the chain of blocks will be transmitted through the network. What a block can consist of? A block can consist of the set of transactions bundled together and formed in a particular block. So each block is linked together, and how they will be linked together based on the header or the address of each block. A genesis block is starting with the genesis block and ending with the end block. In between, all the blocks will be linked together. These blocks will consist the respective data and hash of the previous block and next block, and further link it together, and those blocks will be introduced to the network. So once this is the how the block connectivity will be. See, this is block 1 and block 2, block 3. So these three are this is how the block will be linked together. So the blockchain technique allows digital information to be distributed rather than copied. This distributed ledger provides transparency, trust, and data security. Now, see how the blockchain transaction look like. So if you see here, someone is requesting a transaction, but in traditional method, the client has to send the transaction or the request to the central server, where the central server has to authorize the transaction and send back the response to the client. But here, this node is sending or introducing the transaction to the blockchain network. This blockchain network is, as we have discussed, it is a peer-to-peer network where there are many number of nodes are interconnected together, where the block of transaction is validated by validator. So validation means it is authorizing the transaction and making sure the transaction is correct and secure. So the validation, once the block is validated, and it will be introduced to the network, and miner verifying the transaction. The verified transactions are introduced. The transactions are combined to form a data block. So the blocks again interconnected together. So the chain of blocks will be a new block. Whenever the transaction or new block is introduced, the linkage of the block will be like this. So sequential way, where they are connected together, and the new block is added to the existing blockchain, and the set of blockchains will be bundled together and sent to the destination. So the destination, from the source to destination, the transaction, when it reaches the destination, the transaction is completed. So because the cryptography is introduced here, the data has to be encrypted at the receiver side and decrypted, not in encrypted, it's decrypted at the receiver side, and get the real transaction information, so that here in this way the transaction is completed. So this is the flow how the particular blockchain transaction happens, right? So this is the blockchain transaction. In this blockchain, we are saying, see, core components of the blockchain architecture. How does it work? So what we have seen in the blockchain transaction, we have seen nodes, transaction, block, chain, miners, and consensus algorithm. So a node is any computer within the blockchain network or blockchain architecture, each has an independent copy of a whole blockchain ledger, right? So each node has a blockchain ledger where the ledger is keep tracking the transactions, day-to-day transactions, right? So each node, it can be a either computer or a user that participate in the network. Next is the transaction, is the smallest building block of the blockchain system. It can be either record or information that serves as the purpose of the blockchain, right? That is a transaction. So blockchain, we have seen block, a data structure used for keeping a set of transactions which is distributed to all nodes in the network. So the dust, when you think about the data structure, you can see the body of the data and hash pointers, like a pointer is a hash value of the next block. So the data structure part, it's kind of data structure. So totally block can consist of the transactions and the timestamp and the header of the block or hash value of the hash of the block. So mostly we can say the address of the block, which will point to next block and further previous and next block. So that's how the block will be. And chain is a sequence of block in a specific order, right? So it's simple. It's a linkage of each block one another in chronological way till it reaches to the receiver. Miners. So this node we have seen, right? So this particular node can be a miner. Miners means those who can validate or verify each block before adding to blockchain network. Why they have to verify and validate? Because that particular transaction is to be authorized. It should be correct and secure, so that and it should be immutable. So in order to check all these kind of things, miners will be helping in verification process. Now, if you see the consensus, how the verification process will occur, by using a certain protocols or per certain algorithms. So consensus algorithm is a process in computer science used to achieve agreement on a single data value among distributed process or systems. So the consents or consent of that particular data single value is verified or authorized or agreed upon, and then only that particular transaction is authorized and correct. Consensus algorithm designed to achieve reliability in network involving multiple unreliable nodes, right? If anything is changed, any of the block is changed or altered, immediately the hash value will be changed. If the hash value of that block is changed, then that particular, it is a break within the chain, right? So thus, if it is a break, if there is a break in the block of chains, obviously the hash value is not according to the expected value, so that transaction will be invalid. So however, that particular block should be authorized or consent by using the consensus algorithm, means everybody has to agree upon a particular data value that is being verified. So consensus is one algorithm or one protocol which is used for authorizing or verifying. Next, characteristics of the blockchain. So as we know, because it is a decentralized distributed ledger, the shared lifetime history of an asset or a transaction. Participant can validate transaction and verify, identify and ownership without a need of third-party intermediaries. So in client-server model, what happening, the third party or central authority is always involving. Here, because of the shared ledger, it is removing or avoiding. All relevant information can be shared with others based on their roles and access privileges. So we have seen the validators nodes, right? So those nodes can help in validating. So shared ledger will be working like this. And next is a permission. A blockchain for a business network can be set up as a member only club where every participant has a unique identity, and participants must meet certain criteria to conduct transactions. Participants can conduct transactions confident that the person they are dealing with is who she claims to be. And cryptography. Cryptography is a kind of cryptography is a study of encryption and decryption, right? So advanced encryption along with the permission ensure privacy on network, preventing unauthorized access to transaction details and deterring fraudulent activity. So cryptography is a process of securing the data blocks, right, within the blockchain so that it cannot be compromised or tampered, so that that particular transaction is secure. Right, there are different protocols or algorithms that can be used as part of encryption and decryption methods. So we'll see later. Next is the state-based communication. Today, banks communicate via secure messaging architecture such as SWIFT to accomplish tasks, with each bank maintaining its state of the task locally. With blockchain, banks can send messages that represent the shared state of the task on the blockchain, with each message moving the task to the next state in its life cycle. That is the state-based communication. Now, blockchain is helpful for especially financial transactions. Now, many banks are moving towards the blockchain implementation for safe and secure transactions. Peer-to-peer network transaction on blockchain. For business network, participants exchange assets directly without having to process the transaction through intermediaries or central point of control, thus reducing the cost and delays associated with the use of intermediaries. So, because peer-to-peer network, what happening? Any one of the suppose any of the node is down or not working or not participating in the network, so it doesn't stop the entire functionality of the blockchain. So that is a good advantage. And smart contracts eliminate the hassles and delays inherent in contracts by building the contract into the transaction. Through smart contracts, the blockchain establishes the conditions under which a transaction or asset exchange can occur. Okay, so instead of no more faxing or emailing documents back and forth for review, revision, and signatures. So smart contracts are small programs that can be run within blockchain. They are the agreements or the contracts, so which they will be avoiding or removing either reviews, manual reviews and revisions and signatures. Smart contracts will be helpful in this way. And advantages of blockchain, it's time saving because transaction settles very faster. It does not require verification by central authority, and it is very cost saving because central servers, they may charge a huge fee, but due to distributed systems, what happening is less oversight is needed because the network is self-policed by network participants, all whom are known to the network. Intermediates are reduced, right? And thus, participants can exchange items of value directly. Duplication of effort is eliminated, and double spending issue also will be removed. Tight security, because the blockchain is using the features of encryption and decryption mechanisms or techniques. What happens is the block which is being transmitted through the blockchain network cannot be altered, and cannot be free from the fraud basically, and it cannot be tampered or compromised. Any cyber crimes can be avoided. So it's a very tight secure in by using the encryption decryption techniques. Now, if you see the example, what is the difference between traditional network and blockchain network? Traditional networks see the transfer of ownership from manufacturer to the end user. What happening is manufacturer has specifications and its own data within his own database, and when it is transmitted to dealer, he maintains his own set of ledger, and the leasing company, he has to maintain his own set of book or ledger, like that lazy until the end of the scrap management. These are the various these are the various distribute, I mean, ledgers that are being used. So each and every database is having a one copy, and regulator has its own copy. Instead of each one having one copy each, why can't this can be shifted to the blockchain network? So if you see regulator manufacture this node, everybody is sharing the ledge, the same ledger, and it is avoiding the duplication of the data. And not only that, because it is in the blockchain, the data is very secure. The details of the owners and everything is very secure. So that's how this particular blockchain can help us. There are several examples where the blockchain framework is being used. Bitcoin is one example, okay, and Ethereum is one private blockchain network where smart contracts can be possible. And also, we nowadays we are seeing Hyperledger also is a framework built upon blockchain network, right? So, in brief, blockchain blockchain it is a distributed decentralized system, right? So blockchain in its essence is a distributed database system. This means instead of storing files on a single computer, information is stored across millions of computers or the all over the globe. Blockchain technology disrupts this and gives end user the power to control their personality, identify information. So this is the end of the blockchain just introduction. I hope you understand this particular introduction.